Hello guys, welcome back. Let us see the problem of the day from the LEETCODE. Problem number is 2958. It is length of longest subarray with at most k frequency. It is a medium problem. Let us read the problem. You are given an integer array nums and an integer k. The frequency of an element x is the number of times it occurs in an array. An array is called good if the frequency of each and every element in that array is less than or equal to k. Return the length of the longest good subarray of nums. A subarray is a contiguous non-empty sequence of elements within an array. It is saying that it is giving a array called nums and integer k. We have to find the longest subarray so that the frequency of each and every element in that subarray is less than or equal to k. Let us solve example 1. Here the nums is 1 2 3 1 2 3 1 2 3. Here k equal to 2. So we have to select the longest subarray so that the frequency of each and every element in that subarray is less than or equal to 2. Here if we select 1, it is frequency is 1, so we can select. Here we can select 1 2 or 1 3. Here we can select longest subarray is 1 2 3 1 2 3. Here in this subarray the frequency of 1 is 2, frequency of 2 is 2, frequency of 3 is 2. So that it is the longest subarray, we can return the length of the longest subarray. It is 6. Let us say example 2. The nums array is 1 2 1 2 1 2 1 2 1 2. Here k equal to 1. So that we have to select subarray so that frequency is less than or equal to 1. Here the longest subarray is 1 comma 2. So that we will return 2. Let us read the example 3. Here the nums array is 5 5 5 5 5. And the k is 4. So that we have to select set of continuous subarray so that the frequency of element is less than or equal to 4. Here the subarray is 5 5 5 5. So that we will return 4. Let us see the constraints. Here the constraints are the length of the array is 10 power 5. So that we can't use big of n square. So that we can use either big of n, big of log n, or big of n log n. Here the element can be 1 to 1e9 positive integer, and the k must be within the range of nums of length of the nums. Let us think about the infusion. Here the main thing is we have to retrieve the longest subarray or subarrays so that we can keep track of the longest length of the subarray, and the frequency of each and every element in that subarray must be less than or equal to k. Here we can do one thing is that we can take all the subarrays that from the nums array, and we can check each and every subarray so that if the subarray satisfies the condition that the frequency of each and every element in that subarray is less than or equal to k, we can store the maximum length into the maximum length variable, and we can return that maximum length. Here it will take big of n square for brute force. Let us see the big of n, so that we have to use the two pointer approach. Here the pointers are I comma j. At the beginning it is pointing at the beginning of the array nums, and we are keep tracking of the maximum length of the subarray in max length variable. Here we are using map, that is mp, so that we can keep track of the frequency of for a particular element. We will travel till the j pointer, that is rightmost pointer, is less than n, so that it won't exceed the length of the nums, so that we will get error. At every time we will increase the right pointer by 1, and we will store the maximum length in max length variable. Here at every time we are increasing the frequency of the particular nums of j value by 1. It is 1. Here we are first retrieving the value of the frequency of that particular nums of j previously before this pointer, and adding 1 to that particular nums j, so that if the mp of nums of j is greater than k, so that we will increase the left pointer by 1 till the mp of nums of j is less than equal to k, and I must be less than equal to j. And at every time we know that we are increasing the length of the subarray by 1 because the right pointer is increasing every time. At every time you have to keep track of the max length. Here if we see the, if we select two here 1 2 3 1 2 3, here I equal to 0, j equal to 5, so that the length must be 5 minus 0 plus 1, so that j minus I plus 1. That's why we are doing j minus I plus 1. It will keep track of the maximum length of the subarray that satisfies the above condition, so that at last we will return the max length. This is the Python code. I think you have got the idea and intuition and how to code the problem. And here the main idea is the constraints. Constraints won't allow us to solve the problem with big of n square, so that we must use two pointer approach. It is a basic template here, while loop. Yesterday also we have seen the similar problem. Here the basic template is while loop. First we will travel till the end of the nums, and at every time we will increase the right pointer by 1, and we will keep track of the length or what the question asks. And if the condition fails, we will use while loop and increase the left pointer, and we will take within the condition. I hope you understand the coding part and the intuition part. Thank you.